Hi guys, welcome to our channel of Sciences and Mathematics. Today we are going to learn a new concept in mathematics, and that is concerning determining or finding the determinant of a square matrix. And we're going to limit ourselves to matrices of the order 2 by 2 or 3 by 3. So for that case, of course, this is going to assist us in knowing how to use different strategies in finding the determinant. But the basic ones that we're going to learn is the one that we're going to recommend for finding determinants of simple solutions of matrices. So for that case, thank you and welcome. So as I've said, today's topic is going to be finding determinants of matrix of order 2 by 2 or 3 by 3. So this is our determinant of matrices of order 2 by 2 or 3 by 3 matrices. So in this case, these are basically square matrices, since they have the same order. That's an n by n matrix. So in this case, we can see that this aspect of finding determinants are defined on square matrices that have given us a 2 by 2 or 3 by 3 matrix. So suppose we have an example of a matrix that is a 2 by 2. We can just use our example of A, 2 by 2 matrix that is represented by A. So generally we say that A can be represented as, this is 2, 2, this is A, this is row 1, column 2, and then this is A, row 2, column 1. So that's how generally we can be able to represent that matrices. Then the determinant of this particular matrix can be represented as determinant of A, which is given as A. It's written as such, so we have A 2 2 minus A 1 2 A 2 1. So of course this is the general representation of a 2 by 2 matrix that we have given as A, and this symbol represents the determinant of that matrix. Now the answer for the product for this is going to be a scalar, and bear in mind that we had a different definition for the 1 by n matrices that we refer to as a vector. So for this case, the determinant for this is going to be a scalar quantity. So given an example that we can say, maybe we give you a specific example. Let A be a 2 by 2 matrix or a square matrix that is given as 1 2 3 4, and we are requested to find or compute the determinant of A. Now we can find that one by the solution to this will be the determinant of A, which is given as A is equals, as we have said, we multiply the elements which are this one we defined it as a principal diagonal, so we can just multiply the elements of the principal diagonal, which is 1 by 4, minus this is minus 2 actually. That element is negative 2, so we have minus 2 by 4, 2 by 3, this is 2 times 3. So that is going to give us a scalar quantity, which of course this is 4 minus 6, which is minus 2. This is a scalar quantity, so this is going to be the determinant of this specific kind of a matrix. Now suppose we are given another example, of course, which is going to appear in form of maybe an unknown elements or an equation. Then how can we be able to find the determinant of that kind of a matrix. So given that maybe given that the determinant of A, or A is represented by y3 and then y minus, this is 2, and we are requested to find the determinant of this matrix, then we can say the determinant of A, which is A. So we multiply the elements on the diagonals, so that's y by y minus 2 minus y times 3. So this is going to give us y squared minus 2y minus 3y. So the two like terms for this is a y, 3y, 2y. So it will be y squared minus y minus, of course, okay, just a minute. So this basically, given that the determinant of this, just a mistake here, given that the determinant of this was equivalent to 0, so it's given in form of an equation. So for whatever that we find on our side here will be equivalent to 0. So therefore I just eliminate that one and equate it to 0. So that's the way it appears. So in this case, we can be able to simplify this kind of an equation by just having to divide by y on both sides. And then we find that this is a y minus 2 minus 5 is equals 0. So basically, which is going to give us y is equals 5. So in this case, this is a scalar, still a scalar quantity. So given given a determinant of this nature, we can be able to use it using the concept of algebra and try to solve out that equation. So we can find a solution for y using that procedure. So this is special kind of a matrix whose determinant. So a matrix whose determinant is 0 is a singular matrix, just like the one that we have solved above. It's what we call a singular matrix. So generally it's given as, so we can just give an illustration for that. So if we find that a determinant of a particular matrix that is given as A is equals to 0, then we call this one a singular matrix. So that's a statement, maybe it's going to assist us somewhere. So if a matrix, so the determinant of a matrix is equals 1, then the matrix is said to be unimodular. So this is a 1 unimodular. So those two statements are going to be applicable somewhere. So for a 2 by 2 matrix, we have said that the determinant can be generally given as the difference between. So suppose this is a determinant, a matrix M that is given as that. We have said that the determinant can be given as AD minus BC, and it is given with particular order. So for that case, as a general representation for matrix, and we have said that a determinant whose of course or a matrix whose determinant is 0 is known as a singular matrix, and then a matrix whose determinant is 1 is known as a unimodular matrix. So suppose we have a 3 by 3 matrix, then how can we be able to determine its determinant? So let's give an illustration or a general example for a 3 by 3 matrix. So suppose our matrix A is given as A. So I'm going to use the position of the order, the numbering of the position of these specific elements. Writing this is 3 3, and then this is 1 2, this is 1 3, and then we have this is 2 1, and this is 2 3, this is 3 1, 3 2. So those are the specific positions for rows and columns of this particular matrix. Now for this kind of a matrix, we are going to find the determinant by using this particular order. So we are going to use this particular order whereby, just use a different illustration. So we're going to find the determinant for this kind of a matrix by trying to look at this row and column, and then at this point of intersection we take this element. So it's therefore going to be 1 1, and then the determinant of this part that is left, this is A22, A33. So I write it like this. So this is A22, A23, and then A32, A33. So it's going to be like that, and then you find the determinant of what is in there. And then next we shall have minus, so this is the second order that we are going to follow. So this is minus this one and this. So we take this second one, which is A12, and then we find the determinant of A21, and then A23, and then A31, and then A3. So that's A31, A33. Now suppose you are asking yourself, where are we getting these elements from? So when we try to cross these two, then we will be able to remain with this one, using it as of course as a common factor, and then we are going to have these remaining parts, which is A21, this one, A23, this one. The elements which have not been slashed or just cancelled out using these lines are the ones that we're going to find the determinant in those. So then plus the last one. So if I do away with this and then perform the same procedure for this, I'm going to find that the common one I'm going to have is 1 3, and then I find the remaining ones, which is A21, A22, A31, and A32. So finding the magnitude of that one, then if we perform the same operation as we have done for the 2 by 2 matrices inside there, then it's going to give us, of course, the product. So we are going to use a specific example to try and illustrate this procedure so that we are able to comprehend the steps on how to find a determinant for a 3 by 3 matrix. So I can say let our matrix A be given as, or the determinant be given as 5 4 3 2 0 -1 -3. This is 1 2. So basically this is just a matrix. Now in finding the determinant for this, we're going to find, I've said that we're going to take this first row and column, and then this character that appears, element that appears in this junction is the one that we're going to use as a common one. So we shall have 5, and then the determinant 5 times the determinant of this remaining one. So suppose I just take this and this out, then I will have 0 -1 1 2, and then minus the second one. If I take the first row and the second column, I will remain with this will be, because it's a minus, and then I'm going to have a positive. So generally it's a minus, but since we have 2, then I'm going to have a positive. So -2, the common factor that it should appear here is a negative from the element in the matrix. So because of the odd operation that is a minus that should be here, so it's a minus minus, gives us a positive sign. So we shall have 41, or just 41, read to the determinant of that. And then the last one, the character that appears, I'm supposed to have an addition, the character that appears from these matrices. This is an element at row number 1, column number 3 is negative 3. So still I'll have a negative 3. It's a continuation. And then I have the determinant for 4, 0, and then 3, negative 1. So basically I've applied the rule that I've written for finding a determinant of a 3 by 3 matrix. And then this one is going to give me 27, which is a scalar, of course, as we had determined for the first one for a 2 by 2 matrix. So given that you have been asked to find the determinant of a matrix, which is of course a square matrix, and as we said that the determinants can be defined on square matrices, so therefore for a 2 by 2 and a 3 by 3 matrices, we'll be able to use the procedure that we have defined in order to find these scalar products or answers that we have written on the board. So for that case, that's the procedure. I hope that given a problem that is concerning matrices and one is asked to find the determinant, you can be able to apply the concepts that we have discussed to find the answers. So for that case, thank you and welcome. Bye.